Next page, page number 3. Consider the following diagram. So this is the unit circle. In a unit circle, we have a right triangle. Okay, so x coordinate stands for cosine theta. Y coordinate stands for sine theta in a unit circle. So using basic trig, solve for x in terms of theta. So we will see what to do. So what can I do? X and y, right? All right, so x is going to be what? No idea. And then let's say this is the angle, this is the opposite side, and this is adjacent side from the angle theta, right? And this is the hypotenuse. So let's do SOHCAHTOA. I want x in my equation. So what do I need to use with number 1? SOHCAHTOA. Okay, so I'm going to choose ka for the equation. So cosine theta is defined as adjacent over hypotenuse. What is the length of hypotenuse in a unit circle? Unit circle has radius 1, so this is always 1. So x can be written as cosine theta. That's why we say in a unit circle, x coordinate is cosine theta. Okay, let's do the same thing once again with the y variable. So I'm looking at angle theta and y, so that is opposite side. And I'm going to use number 1 again. So I need to choose so let's talk about sine theta. What is ratio for triangle, right triangle trig? Opposite over hypotenuse, which is 1. So y will be sine theta. So every point on unit circle has ordered pair. That is cosine theta, comma, sine theta. Okay, that's why we have this right triangle in a unit circle. So let's talk about Pythagorean theorem. X squared, y squared equals to 1 squared, right? So that's Pythagorean theorem, and we will use x and y from above. So we can plug in. That is giving us cosine squared of theta plus sine squared of theta equals to 1 squared. So that is called Pythagorean identity. Let me rewrite it. Sine squared of theta, cosine squared of theta equals to 1. 1 times 1 is 1. So that is Pythagorean identity. So we memorize that. So now let's think about how to rewrite this way, okay? If you are studying for calculus, you must memorize this. So you can move to the next thing quickly, okay? As you see this, you need to recognize, oh, this is one of the variation of Pythagorean identity. So let's start with sine squared theta plus cosine squared of theta equals to 1. And let's create this one, okay? Let's drive this formula. So look at the formula. What do I have? Secant, right? So how do I get secant? Secant is a reciprocal of cosine. So I'm going to divide everything by cosine. Cosine squared of theta, cosine squared of theta, cosine squared of theta. So let's divide both sides equally by cosine squared of theta. And then let's drive the identity. So from the first term, what do I have? Tangent squared of theta. From the second term, what do I have? 1. And third one on the other side, that is secant squared of theta. So this is driven from the Pythagorean identity. So this is different way of writing the same thing, okay? All right. Last one, can I derive this then? Let's try. So let's start with Pythagorean identity, sine squared of theta, cosine squared of theta equals to 1. What would you like to use to create cosecant theta? Let's divide everything by sine squared of theta. So by doing that, on the other side, I have a reciprocal of sine squared of theta, which is cosecant squared of theta. Okay, so let's simplify. What do I get from first term? 1. From the second term, that is cotangent squared of theta. So we can derive the third form of the Pythagorean identity. Okay, so that's how we derive the things. And Pythagorean identity, you usually memorize the first one only, but we have different variations. It's same thing, okay? And I can remember all of those sometimes, and then I know how to derive it, so I can create the formula quickly. So I can think about all of those, okay? So memorize at least one, and then remember how we derive the formulas, so you can do anytime. So let's see, number 14, can we simplify by using reciprocal quotient and Pythagorean identities? Do you see Pythagorean identities in the format? I see it. Do you see it? This is part of this side, right? So let's rewrite it. What is that? 1. 1 over sine theta. Can we rewrite by using reciprocal identity? Yes, so this will be cosecant theta. Okay, next one. What would you like to do if you see parentheses with plus sign in the middle? What would you like to do? Let's do algebra, okay? Can I distribute and multiply? Sure, let's do it. Sine theta times sine theta is sine squared of theta. Next one, let's write it. Sine theta times cosine theta times cotangent theta. And then let's expand it, okay? All right, so let's rewrite which part? Cotangent. What is cotangent? Cosine theta over sine theta. So let's rewrite if we can do it, okay? So we can simplify. Yes, we know something will be canceled out, right? So this will be canceled out. In the next step, I have sine squared of theta plus these two together makes second power. So now I see Pythagorean identity once again. Do you see that? So this will be 1.